Thank you for visiting my YouTube channel. I know you want to watch the video. Before I get into the content, I'm going to talk about my nonprofit, the Accelerated Training Program, a cybersecurity and digital literacy nonprofit based in Charlotte, North Carolina. We are looking to provide accessible cybersecurity education and digital literacy skills to underrepresented groups from the K through 12 space right now, but we have on our roadmap collegiate, elderly populations, etc. Pretty much anyone from an underrepresented group. We want them to get cybersecurity education and digital literacy skills to bring them into the ever increasing digital world that we live in now. If that sounds like something that you're interested in, we do have a donate button if you would like to donate monetarily. We're always accepting donations. If you would like to volunteer your time, we have a volunteer tab where we're looking for workshop volunteers. Currently, we have 1 month workshops, but we're looking to expand that in 2024. Board members, advisory board members, and a grant writer. So if you're a grant writer, if you have experience in grant writing and also winning grants, we would definitely love to have you on our team. To be considered, please complete the volunteer form here, which is a link that will navigate you to a Google form. And again, we're a cybersecurity, digital literacy nonprofit, and we would love to work with you if that is your passion as well. Thank you. Have a good day. And now the video is going to start. Hello, and welcome to day 21. We're still in the DevSecOps category. You'll be poisoned, a pipeline of insecure code. Oh my God. We are 4 days away from Christmas. Let me start the machine. Okay. And it looks like we're going to need the attack box. Okay, let's start reading. One of the main reasons for acquiring the crafts was for their crafty, I see what they did there, automation and gift giving, wrapping, and crafting. After securing their automation, they discovered other parts of their continuous integration, continuous delivery environment that are used to build and extend their pipeline. An attacker can abuse these build systems to indirectly poison the previously secured pipeline. Oh no. So, the learning objectives: understand how a larger CI CD environment operates, explore indirect poison pipeline execution, PPE, and how it can be used to exploit Git, apply CI CD exploitation knowledge to the larger CI CD environment. So, in this lesson, we're going to need the attack box, which is starting here, and the VM, which we started. So, let's read and then wait for the attack box to load. CI/CD environment. Often, developers or other end users only see a limited portion of the CI/CD pipeline. Developers interact with Git on a daily basis, so it makes sense that CI/CD is mostly commonly associated with Git. Although it only makes up a quarter of a typical CI/CD pipeline, the diagram below visualizes the general segments of a pipeline: development, building, testing, and deployment. While these segments could be expanded and interchanged, all pipelines will follow a similar order. Okay, so we see development, build, testing, deployment. So this is the continuous integration, and then this is the continuous deployment. But for all phases, you have continuous monitoring. In the previous task, we looked at a CI CD environment that was self contained in Git. In a more formal environment, segments of the pipeline may be separated out onto different platforms. Below is the CI CD environment we'll be exploring in this room. You notice the addition of Jenkins, a build platform and automation server. In the next section, we will explore Jenkins and discuss how these components interact and contribute to the pipeline. So we have Git T, Jenkins, and then the Jenkins agent. So, automation platforms. Jenkins, along with many other applications, handles a pipeline's build segment. These platforms can be remote or local. For example, Travis CI is a remote build platform, whereas Jenkins is a local automation server. These platforms rely on runners or agents to build a project on a pre-configured VM. One advantage of some automation platforms is that they can automatically create and configure build environments on demand. This allows building and testing in different environments without manual configuration or administration. Okay, so the indirect poison pipeline execution. Let's briefly shift our focus back to the development stage. In the previous task, poison pipeline execution was introduced, wherein an attacker has direct write access to a repository pipeline. If an attacker doesn't have direct write access to a main protected or branch protected repository, for example, it's possible they have write access to other repositories that could indirectly modify the behavior of the pipeline execution. If an environment is deploying a development pipeline, a configuration file must be defined for the steps the build system must take. If a repository contains all the necessary source and build files, and another repository contains the pipeline files, write permissions could differ between the two, resulting in an indirect PPE vulnerability. In this example, you can assume that the repository containing the source is not write protected, and the repository containing the pipeline is write protected. To exploit this vulnerability, an attacker would need to identify a file or other parameter they can arbitrarily change that the pipeline file will use. Make files and other build files are usually exploitable because they are used to build the source and can run any arbitrary commands as defined in the make file. Below is an example of what this might look like. So we have stage, steps, and build, and then we have this sh, make, and then true. To weaponize this vulnerability or PPE in general, the CI/CD environment as a whole must be taken into consideration. For example, if a build server is used to build artifacts on a pre-configured virtual machine, an attacker could run arbitrary commands in that environment. So the practical challenge. Now let's apply what we have learned in this task to the craft CI/CD pipeline. So we are going to open. Okay, and then we're going to go to the particular IP address. 1010. Uh-oh. 10.167, 97, 3000. Okay. The Git platform Crafts uses for version control and development. Log in using the credentials guest password 123. So let me sign in. Okay. When you have logged in successfully, you'll see two repositories, gift wrapper and gift wrapper pipeline. Navigate to HTTP. Okay, so I'm going to open another tab. And this is 8080. Okay, the Jenkins platform crafts uses for the building and for building and automation. Log in with admin. Once you have logged in successfully, you should see a project gift wrapper build. Before looking at the environment's other components, let's dig deeper into the Git repositories. Looking at the gift wrapper pipeline repository, you may notice a Jenkins file. If a repository is unprotected, an attacker can modify a pipeline file to execute commands on a build system. For example, an attacker could control the build stage by modifying make true to who am I. This is possible because the Jenkins files allows you to run shell commands, as you can see on line 13. This is an example of PPE as covered by the previous task. To modify the Jenkins file, we will use the power of Git. To begin working with the repository, a local copy must be created or cloned from the remote repository. In this example, Gitia. Run the command below to clone the GIF wrapper pipeline repository locally. So what that means is we're going to download this repository into the attack box. Okay. Once cloned, we can make any changes we wish, then commit the changes. To start, we can exploit PPE by changing line 13 of the Jenkins file from sh make true to sh who am I. When a commit is created, a snapshot of the current state of the project is saved to the local repository. To our commits after modifying the Jenkins file, run the commands below to add, commit, and push your changes. Okay, so okay, so we're gonna change this to who am I? Now we're gonna say git add, git commit dash m is for message, updated Jenkins file, git push. Okay. Oh, okay. Username is guest. Okay. So why did this fail? Um, okay. Okay. So we got when attempting to push the changes to the repository, you notice that it's main protected. You can also try creating a new branch, but you'll notice the branch is branch protected too. This means we need to find another way to indirectly modify the pipeline so it's working as it should. Looking at how the Jenkins files work, you may notice that it uses make. If you recall from a previous section, a make file can be used to define a set of rules to execute steps, such as commands. The make file is defined in the Gift wrapper repository, meaning it could have different protections than the pipeline repository, and an attacker could add malicious commands to it. After you After also cloning and attempting to push changes to the GIF wrapper repository, we see that our commit is successful. Depending on the configuration of the build system, different actions may initiate a new build. In this example, we have access to Jenkins, so a build could be manually scheduled by pressing the green play button. We can check the status and output of the build from Jenkins by navigating to that IP within the project GIF wrapper build under the GIF wrapper pipeline repository under the main branch name. If successfully executed, the command we poison should appear in the make stage logs. Okay. Okay. Hold on. Okay. So, hold on. I'm going to pop this to another screen. Okay. 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 I'm going to close this. That was my daughter. Okay. Okay. Okay, so we need to. Okay. Okay. Okay, so we're going to say, who am I? And I think, okay, so I'm going to go to Google version. Okay, so uname dash R. So uname dash R. Okay, so I want to say git add, git commit dash m, making changes, git push. Okay, so it was sent because now if we refresh and we scroll, we see right here making changes, which is what I said, and then it's now. Okay, so now if we go to Jenkins and build history. Okay. 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 So Okay, I'm looking for the play button. Where is that? Okay. Okay. Okay, now where is this button? Because I have. Okay, I'm just gonna say scan. Okay, where is the? Oh, right there. Okay. Okay. We can check the status and output of the build by navigating to port 8080 within the gift wrapper build. Okay. Okay. So here is the kernel version. Okay. Now, what is the value found from? Okay, so let me copy this. Okay, I think. Allow. So I'm gonna go here. Oh, okay. This is what I wanted. Okay, so excuse me. Okay, so since this is a bash script, I am going to open this file, and we're gonna see if it opens. So let me. Go fishing. We're gonna push guest password 123. Okay, so that worked because now if we go back here, we refresh. gone fishing. Okay. So now let's go back to Jenkins. I need this. Okay, so I'm going to go to the gift wrapper pipeline. Let's try this again. So let's do the build history. Okay. Okay. Let's see the console output. Okay, and this is what it is. This is our flag. Okay, so visit the Discord, the Try Hack Me Discord, if you're not in it already. So this was a fun room. So let me recap because there was a lot of moving parts. Okay, so when we logged in, there were two repositories, the gift wrapper pipeline and the gift wrapper. We tried to do our commit inside the gift wrapper pipeline because it had a Jenkins file. But when we tried to push our changes, we got access denied because the main and the branch repositories were protected, meaning we couldn't write to it. So then we went to the gift wrapper repository and we noticed that we had a make file that pointed to the 2pip.sh which is a shell script. So from there, we originally did our first commit to include the who am I and the uname-r to get the kernel version, because that's how you get the kernel version in Linux. It's the uname-r. That's what I was looking for. Again, Google is your friend. From there, we went to Jenkins, and then it took me a while because I was like, I'm looking for the green button. So the green button that I was looking for, I can get to it, was here. And so that initiated a build. So from there, we went to build history, and our original commit was in branch 5. And so that showed us. Okay, 5. And then we went to console output. And then if we scroll down, we see Jenkins. So that's the who am I, and then the kernel version 5.4.0 AWS. So that was the first question. Now, the second question is, what is the value found in the secret key? So then what we did was we went back to the pip sh, opened the file in the terminal, added this cat. And so what we're saying in this line is open this file. So whatever is in the secret key, display that to the screen. And then we committed our code here. So we said git add. So we're saying, hey, add our committed file from this folder. So it's like whatever files have been changed, put it inside of Git. Then we said, okay, we want to commit, and the -m is for a message. So this message is gone fishing. Okay. So then it's like, okay, your email and name is not configured. You can do that later. And then we said git push. So now we're saying, hey, push our changes to Git. And so Git's like, okay, bet. Give me your username and password. So I gave the username of guest, password or password 123, which was in the room. And then it was like, you know what? You gave me everything I needed. It has now been pushed and it's now on GitHub. And we can verify that because we see it here. Now, after we added this last line, we went back to Jenkins, and then we executed the build again to pick up our changes. So we press the green button one more time, and then now it's build number 6. And I think this is the console, so we could have just clicked here. Yeah, I just realized that. And so now we have Jenkins, which is the who am I, uname-r, which is the kernel version, and now we have what was in that secrets file, and we have saved it here. So this was fun. This was interesting. I really haven't played with this, the PPE. To pretty much it's transient. So it's like you're doing things in an indirect way. So the first repository we looked at had protection, so we couldn't look at it. So we had to indirectly use another repository to exploit it. So this was interesting. As I said, we're 4 days away from Christmas, so let's see what McGreedy and everyone else has in store for us. And I can't wait to see you in the next video. Have a good day. Bye.